Hi everyone. So today's lesson is really a pretty quick lesson just on function notation, and this is how we use some different symbols along with the function stuff that we've been talking about for the last couple of days. So probably the biggest thing for you to take away from this, I'm actually going to start down here where it says function notation. So in your notes packet if you want to follow along with me. Biggest thing for you to take away is this sort of terminology right here is when you see this, f with a parentheses and then x, we say that as f of x. And really that represents a function of x. So the big misconception I always get with this kind of, symbol is people see parentheses and immediately want to think multiplication. In this case, parentheses do not mean multiplication. So that's a really big takeaway. And sorry, my handwriting will get better on this as the year goes on. It gets a little rusty every summer. But okay, so this is sort of the general notation, this f of x. But we can use different letters besides f. F is just sort of our generic one representing function. But depending on what kind of equation we're talking about, we could name it with any letter that we choose. Okay? And then the way this is written, that x just represents the independent variable. Okay? Which should make sense because remember when we said things were a function of x, that this piece always indicated that independent variable. So whatever our input is into our function, that's what's going to go right there in those parentheses. So up above there, you've got this table, right? This right here. And this table kind of indicates some different types of functions that are going on, and they're all a function of speed of the car. So here, x represents the speed of the car. That's your independent variable. And this is discussing thinking distance, braking distance, and stopping distance. So just real quick, if you haven't had driver's training yet, these might not quite click for you. So let me just explain what they're talking about. So this is, in general, analyzing how long is it going to take your car to stop from the time you see, another car's brake lights up in front of you. So thinking distance, that represents just the amount of time it takes for your brain to process seeing the lights and thinking about, oh gosh, I better do something. Okay, so for example, if you're driving 20 miles an hour, your car is going to travel 20 feet before your brain has even registered that you're going to need to stop. Okay, that's what this is really saying. And then the braking distance, that's from the time you actually start pushing on the brake pedal. So your brain has already registered, okay, I need to stop, and then you push on the brake. Depending on how fast you're going, you'll travel different amounts of distance in the amount of time that your brake is pushing all the way to the floor. And then stopping distance, you'll notice, is just a sum of the two of them. Okay, so stopping distance is just these two things added together. That's the total amount of distance that you will travel from the minute that those brake lights go on until your car is at a full stop. Okay? And so this represents three separate functions of x, of our independent variable. And what I'm going to do is I'm going to give each one of them their own names. So thinking distance, for example, and I'm going to shrink this up a little bit here. There we go. Thinking distance, I'm going to name t of x. Braking distance, we'll go b of x. And then because I'm super creative, stopping distance we're going to call s of x. So down here under example 1, when I say evaluate s of 40, remember this notation is saying 40 is my value of my independent variable. 40 is my x value. And what I'm asking for is what is the value of the function s when x is equal to 40? Okay? So I'm going to find where x equals 40, and that would be right here, right? And then I'm looking at the function s, which is this bottom one, and it would be 120. Okay? So what that means is the total stopping distance that you would need if you were traveling at 40 miles an hour is 120 feet. Okay, at 40 miles an hour, you're going to travel 120 feet before you come to a full stop. Okay, that's how I'm reading this table. Now, there was some confusion in one of my classes about like, well, why are we given this table, but then also these crazy equations over here? All of these numbers in the table came from these equations. Okay, so this 120 I also could have gotten by taking this 40 and plugging it in for x in my stopping distance equation. I just don't need to because someone has been very kind to us and has set up this table with all of these values sort of pre-generated. Okay, but we're going to get to one, like in this next example, that doesn't show up in the table, and then we have to use the equation to find it. So in this next one, b of 35, you'll notice 35 is not a value that shows up here in our table. 35 does not show up here. It's going to be somewhere in between here, we know, but we don't know the exact value. So instead of using the table here, I'm going to be focused on these equations. I want function b, that's my braking distance, and I'm plugging 35 in for x. So I'm going to end up doing, I'm going to move this over here, I'm going to end up doing 35 squared over 20. And because I did this problem 3 times today, fairly certain the answer to that is 61.25. You could put that into a calculator to get your actual answer, but again, pretty sure 61.25. Okay, now the next question's a little bit different still. Notice this question is asking you for a value of x. These last two were asking you for values of the function. So they were asking you for s, they were asking you for b. This one is saying, what value of x would I need to get an answer of 180? So notice it's not giving you the number to put in for x, it's asking what x would you have to put in to get 180 as an answer. You could solve this algebraically, or we could look at our b of x row, which is, let's see, this right here. There's b of x. And we want to know what x value gives us a value of 180. Well, that's right here. Okay. And my x value that goes along with that is 60. So my answer here would be x equals 60. Okay. So that's meant to just kind of get you used to the notation we're using here. The math is not too terribly difficult. It's just about recognizing what is the question asking when it's written this way. Okay. So let's move down to example 2. We don't need that table for example 2. Notice this one gives us a function and they only give it to us in equation form. F of x equals 4x minus 3 over x squared. So when I'm asked to find f of 3, remember what they're really giving you here is your x value. So I'm just going to plug in 3 in place of x. 4 times 3 minus 3 divided by 3 squared. Okay, 4 times 3 is 12. 12 minus 3 is 9. And then on the bottom, 3 squared is also 9. You could put this into a calculator if you wanted to. If you wanted to put it all in your calculator in one shot, make sure you put the top and bottom in their own set of parentheses. Okay. And then 9 over 9 just simplifies to 1. Okay. So let's try f of negative 1. Same idea here. I'm going to switch colors just so you can tell the difference between the problems. So for f of negative 1, I'm plugging in negative 1 for x. So 4 times negative 1 minus 3 all over negative 1 squared. Notice I put that negative 1 in parentheses when I squared it. That's going to be a really important concept this year. You're going to hear me talk about that a lot. When you square or when you raise a negative number to any power, you have to put it in parentheses. So 4 times negative 1 is negative 4. And then negative 4 minus 3 will leave me with negative 7. And negative 1 squared, your brain is smarter than your calculator. Negative 1 squared is just positive 1. And negative 7 over 1 is just negative 7. So what I'm really doing here is coming up with those pairs, coming up with those ordered pairs that are within my function. So like this first example, this is telling me that 3 is paired up with 1. So like 3 comma 1 would be an ordered pair. Here, -1 is being paired up with 7. Okay. Now, this next one's a little different, and it looks complicated, but it's actually quite easy. Just like before, whatever they're giving me here is what they want me to put in place of x. So here, when they give me f of n, all I'm really doing is plugging n in place of x. So that's going to look like this. 3n, oops, minus 3. Nope, just kidding. I knew there was something wrong there. Sorry. 4n minus 3. Copied my equation wrong. Over n squared. Now my favorite question on one like this is, do we have to solve it? Well, there's really nothing to solve. It's not set equal to anything over here, so I can't solve backwards and find what n is, and they don't give me a value of n to plug into the equation or into the expression. So I really can't do anything else with it. I just have to leave it like that, and that's just my answer. Okay, and that's okay. So on this next one, I'm going to take 3k and plug it in for x. So that's going to look like 4 times 3k squared. Nope. Oh gosh, I'm just making stuff up left and right today. 4 times 3k minus 3 all over 3k squared. That's where that was coming from. And then in this one, I still can't solve it, all right? I can't boil it down to a single number, but I can simplify it, all right? I can say 4 times 3k, I can put those together and make that a 12k. And on the bottom where I see 3k to the power of 2, remember that means to square the 3 and square the k, so that actually gives me 9k squared. Now some of you who have maybe seen some of this algebra stuff before, you may be yelling at me right now that, hey, there's something else we can do with that. If we were to do some factoring, we could simplify this even further, but we have not touched factoring yet, so for our purposes right now, this is good to go. Okay, we're just going to leave this alone because there's nothing else we can do with it right now. So that's really it. Again, the goal of today was really just to be able to recognize this type of notation, this type of notation here, and know what to do with it, and possibly even apply it to a real life situation, which, sorry, I'm trying to shrink everything here, which we did up in this first example with the braking distance and the stopping distance and all of that. So, your homework for tonight is to finish up that Lesson Master 1-3A if you didn't get a chance to do that last night. And then you do also have a homework check posted in Blackboard for you. Okay? And feel free to contact me with any questions.